Any public comment online? Becca? Okay, with that, all those in favor, say aye.
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 Anyone opposed? 401 again. Here, moving into item 5 in our agenda, reports. Operations report. Damon. Always enjoyable.
Good afternoon, directors. Happy to share with you some interesting operational items from December of 2025. We'll just dive right in. Okay, as we like to start every operations report with Jenny Lynn distribution system, it's no different here. So, example of service line replacement on Hotley. As you all know, we have a utility crew focused solely on replacing service lines. Right now, they're on Baldwin, so they're going to continue down Baldwin and Rancho Calaveras until those services are completely replaced. Oftentimes, the distribution crew, which is a separate crew completely, will expose a service line to make a repair and then find themselves in need of replacing it. And that's kind of this is an example of that. So they blow down, they see what's going on, and then they just make the call that they're just going to replace the service. And in this case, you can see it's a dual service, we call it, to two different meter sets. The bottom picture on the image on the right. Okay, and then this is an interesting one. So this is at the La Cantera waste plant. So we have a potable water service that feeds water to the La Cantera waste plant for, as you can imagine, any number of things, but most notably, there's a bathroom there and there's a sink and there's a laboratory. And but this is on CCWD property. The water line was installed years ago. This is a large area. So our guys had a general idea of where the water line is. However, they don't know completely. So they have to expose the line and then follow it. And so this is kind of what they're doing here. And they note that there's a buried valve in the image on the right. There's a coupling in the image on the left. There's a T. And then they continue to look for the leak, the source of the water. The first thing we had to rule out on this location is that it wasn't wastewater. It wasn't sewage, and it wasn't leaving the property. And that was very important, right? Because if it was, we would have had to report a spill, essentially. So the guys continue to look, and then the construction crew gets involved because we notice on a rainy day that then when the blowers at La Cantera kick on, you could see air coming out of the asphalt from the laboratory building. So we might need to take a look at that airline. The airline is large, it's 12-inch. So as our team exposes the 12-inch ductile iron line in the image on the left under all the electrical conduit, start to assess how we're going to replace this because that aggressive soil has eroded that ductile iron pipe away. Lo and behold, the crew finds the source of the water line leak in the image on the right. You can see that coupling and you can see water spraying out of that coupling. And so they make a repair. So it's often like one work effort flows into another. So we have this exposed 12-inch ductile iron line that you guys can see is significantly corroded that needs to be replaced. So we start developing an operational plan. The construction crew of Pat and his team and Jesse and his team get together and talk about how you're going to work through this issue and replace this line. And then you make the water. So
the damage we saw on the larger plant is due to the water spraying on it, the combination.
Well,
It's
no,
only that section.
no, it's unfortunately it's the entire line, which, so if you can imagine that line just kind of extending straight, and then there's a basin on the left of it that holds sewage, and it's being aerated. So we're allowing this natural process to take place. There's microorganisms that are eating the solids in the sewage. We're going to decant that water, filter it, send it off down on its way. This line provides air to that whole process. So it's almost a football field long. And it drops in size. So it goes from 12 to 10 to 8, to 6 to 4. And unfortunately, the engineering team has informed us that this area and the work that they have done related to the design of the new facility, the soil is aggressive. And so unfortunately, the line was not wrapped. And so this is from the soil. Yeah. Here's an interesting one. So the image on the left, this is an air relief valve. So you can imagine a water line needs to evacuate air periodically. So you're going to put in an air relief valve at a critical point. And as air flows through the water system, it could be an entrained air, it could be dissolved oxygen coming out of solution. It's going to burp essentially out of that air relief valve. And those are prime targets for vehicles. Cars love to run them over. There's like a magnetic attraction to air relief valves. And so they're often destroyed. And so what you see here is the line, the mechanism on top of the standpipe, if you will, was broken. So our crews unthread that standpipe. They have to shut the water line off, unthread the standpipe. You can see it in the middle of the vise in the truck. Then they install a new standpipe and put a new air relief valve on, and then backfill the standpipe line with usually like AB rock and drain rock. And so put it back in service. And so there's a float inside that green mechanism that it'll, as air comes in, the float drops, and the air can burp. And then when the water comes back in, it seals the valve, and that's an air relief valve.
How close are those? They stay that far out of the ground and they're pretty close to the roadway?
They can be well off the roadway. They're in any number of places. Yeah, sometimes when we can, we'll install bollards, protective bollards in front of them, depending on, where they're at. Usually they'll have a box, some sort of cover over them. They can be subject to freezing depending on what size they are. So that's also an issue we have to pay attention to depending where they're at. This was, you can get an example of kind of some of the conditions of our pressure reducing valves out in the field. This is in the Jenny Lind service area, Garner and Frieden. Pressure reducing valve. So you have a large valve, and you usually have a bypass valve. And so the work here, it's a little convoluted, but in the image on the left, you can see they're taking apart the large valve to replace the components inside. There's a diaphragm, there's small operating equipment and components. And then the bypass valve, they just replaced completely. So in the image on the right, you see that nice clean blue apparatus kind of in the middle of the picture. That's the brand new bypass pure. And then some more images of the two kind of close up. Before replacement on the left, after replacement, that nice dark blue one on the right. We have buried valves all over the system. So as our folks find them, they like to expose them and work to ensure that they're not buried again. So you can see that we poured some concrete slabs around these valves and then built a retaining wall so that soil doesn't cover them up. And then you're going to go try to find a way to isolate a section of your water system, and you're going to spend 4 hours with a metal detector walking around looking for a valve that's buried under 6 inches of dirt. And so this eliminates that effort and makes things more efficient in the future. These are some interesting.
I just gotta say, your pipe work is beautiful. Retaining wall needs some help.
We need some love there. I would call that a utilitarian retaining wall, right?
Okay.
We'll get some landscaping block out there. Yeah.
So some people use mortar between the blocks. But
Well,
Was it at least clay?
yeah, I think there's some bar in there.
Yeah.
Bar's going to keep it straight.
looks like it was backfilled with native.
I think we're going to coat it with, some leftover elastomeric coating you might have on Kevin. Coat it with some of that. Rhino line it. We could do that too. So there's this building that used to exist at Vallecito that we've moved all over the service areas. And here's another example of that. The construction crew moving this overhang building that we're going to use to cover rock and material in La Quintana. Some of you may have heard of this. There are some manholes in the Woodgate subdivision that there's a swale around the collar of the manhole. And CCWD is working to reestablish the grade on the manhole lid there. So we've saw cut around the manholes. This is a job that's in concert with the county. The county's going to go in there and reestablish the grade on the roadway as the district repairs.
Where's Woodgate?
This is Vista del Lago North. You hang on the left.
Oh, okay.
Yeah, Warmwood, Woodgate. Yeah.
Across the street.
Yep, across the street. Now we're jumping up into West Point. Another example of our folks' ability to listen for a leak and make a repair and expose the leak pretty much right on top of where it is occurring. And so obviously we want to minimize patches in the roadway. And so it's really, it's important that our folks listen and find an accurate, mark an accurate location to dig. And this is an example of that. Hats off to Doug and his team up there. It's a team of one. Barney Way on the left, another example of that. Image on the right, so Middle Fork Pump Station, we put boards in those concrete dam bollards to establish some backwater conditions so we can actually ensure that we have enough volume to pump in the summertime. And then when the winter comes, we need to get those out of there, because if you have a portion of a tree coming down, it can really wreak havoc on the system. And there's also a treated water line right under that area set in concrete. So you can imagine if you have bollards and backup, you can.
This is where the intake is for the CPUD transfer, water transfer?
That's correct. That's right. Yep. Yeah. So this is kind of, if you were standing there looking at this in real life, right to your left would be the pump station, where the water is conveyed in a pipe that sits at the base of those bollards and feeds one large wet well, which we have 3 pumps, I believe it is, 2 pumps in the Middle Fork pump station that then will take that water and convey it up to the treatment plant.
In a heavy rains like we had recently, how far up those bollards will that stream rise?
Oh, right, all the way over. Yeah,
It can still be taken out. Tree came down.
potentially. Yeah, that's true. That's true. Here's a great project, kind of tipping the cap to the work that our construction distribution crews do relative to ensuring that we have as many fire hydrants operational as possible. This is replacing 2 very old fire hydrants on Bald Mountain Road in West Point. It's kind of hard to see in the image on the left, but there was a service line that it was actually tied into the 6-inch main right downstream of the fire hydrant T. And then the service line itself wrapped around the fire hydrant before it made its way over to the water main. And then the customer's private plumbing then came back towards the fire hydrant, which you can see in that pipe kind of at the top of the left-hand image. So making sense of all of that on the fly is kind of an art, and our guys do that every single day. So hats off to them. They need to know what pipe to disconnect and what pipe to leave live. And so this is an example of that. You can kind of see that service in the image on the left. There's the concrete pour on the fire hydrant kicker on the right, the old hydrant being taken away, pulled out of the hole. And so an example of the backfill and compaction of the brand new fire hydrant installation there with the valve, G5 valve access in front of the hydrant. So you can isolate that hydrant if somebody decides to run over it and water shoot in the sky, rather than shut the whole universe off to turn the water off. You can shut that valve right there. And here's kind of a before and after. So this is kind of the old hydrant on the left that's questionable operation. And then the image on the right, the sanitary concrete apron, the G5, and then the brand. Hats off to the crew for those. This is a great, I love to share the lift station screen at the West Point lift station. So this lift station is on the pumps that push the liquid sewage through a force main, a couple miles cross country, over in a bridge, actually, over to our West Point wastewater treatment facility. And Grease loves to collect on this screen. And so our folks, Doug will pull this screen every quarter and hot flush it, get all that debris off of there so the pumps can continue to operate without pushing up against a head that they can't accommodate. This is a really interesting one in West Point. So the image on the right is a sewer lateral. Somewhere along the way, this lateral was capped. And it was going, long story short, our folks found that it went to a septic tank that was in a community garden that's no longer in use. So somewhere long time ago, somebody decided to cap it. And you can see I don't know what that is, whether that's some asphalt. It looks kind of like duct tape to me in the image on the right. So they have a pipe that's capped, and our guys are hydro flushing the sewer system, cleaning it. And in the image on the left, all of a sudden they see water blow up out of the asphalt. They're like, oh my gosh, we blew the sewer line up. Well, come to find out, that top of that capped lateral on the right blew off. And so then the guys understand, oh, this thing was disconnected years ago, 25 years ago. Let's go ahead and find out where it goes, clean all the AB rock that's now in the sewer line out, which as a result, reduced blockage conditions that the fire department had at the firehouse for the past couple of months, because now we understand, oh, this capped line was allowing AB rock to flow in the sewer line and block the fire department's sewage from flowing into the system. And so just kind of a case and example where preventative maintenance can, lead you to issues that you can then correct other issues. So hats off to the guys for finding this as another holiday gift that I don't know if they wanted it, but they found it and they made the most of it. So the image on the right, they cut that cap, they cleaned the debris out of it. You can see it's just full of debris. And then the image on the left is coming from the abandoned septic tank, which they flushed, cleaned, evacuated all that water that's in the hole now, and then they reconnected the whole system. So should that septic tank need to be used in the future in the community garden, it can be used. Now we move up to Evetts Pass. This is a 2-for-1. So there's a 1-inch service line in Larkspur, and there was 2 leaks on it. You can kind of see, just orient yourself. You've got the hole in the image on the right, kind of on the fog line, and then our folks are opening up another hole with the Vactor truck. And you can see the pickup tube there. It's kind of hard to see, but there are 2 separate leaks on that service line. You see all those roots in there wreak havoc on our system. They find a little bit of water, they're going to go in ahead, choke whatever it is they find, and ultimately break it. Here's a better, you can see the water spraying out the top of that in the image on the left. And then just an example of the backfill in the image on the right. And then the reestablishing the asphalt. So if you cut out a section of asphalt, you can keep it intact, drop it right back in. Hats off to the guys on that one. Another 1-inch service line repair up on the pass. Just kind of an example of the variability with backfill material times that our guys find, and their ability to kind of get into small restricted places and make the work happen. You can see in the image on the right, it's kind of just, this one was just off the road, and that CCWD issued an underground service alert. You can see there's power right there. There's a red flag in the image on the right. So our guys all of a sudden find themselves having to contend with power. Curb stop replacement. So you guys get to see what an example of what a curb stop looks like, often connected to your at your meter to your service. This is an interesting one. So wharf hydrant, the image on the right, some people call that a hydrant, and this is a challenging aspect of, a lot of our communities is they have these 2.5-inch or 1.5 inch lines that have this fire hydrant connection on them. And in no way are they going to be able to truly address, fire protection, but they are there. They're available for water as necessary. And so you can see the valve and the age of the valve handle in the image on the left. And these are those the kind of improvements that we can make to ensure that, whether or not this is on a line of adequate size or not, but we can work to ensure that, we can optimize fire protection and at the same time optimize the system. Maybe this works better as a blow off.
What kind of pressure is on a line if you've got an 1.5-inch line?
It's going to vary. It's really going to depend on where it is within the system. I mean, we can have 120 plus PSI, or you can have, 40. There's so much pressure variability throughout the system. And I'm not sure, you guys, Kelly or Pat, you guys might know what the pressure is on Horseshoe off the top of your head. I don't. But yeah.
It's 120 PSI on an 1.5-inch line to do a lot of damage.
You can cut through some stuff. Yeah, right. Yeah.
But 40, not so much.
Right. Here's an example of kind of correcting some issues in the past. So there was this is an example of a pressure reducing valve piping intertie that in the past was broken. And so our crews really wanted to reestablish this connection. So you can kind of see in the center image and the image on the left, there's some basically a concrete kicker sitting on top of the line that used to be intertied to the line at the bottom of the image, the green pipe. And so for years, this has not been connected. So our construction crew worked with the distribution team up there to reconnect these pipes. And this is just the stages of construction. You can see there's a concrete kicker in the image in the middle that needs to be pulled out of there so that line can be reconnected to that T. And then the work continues. The image on the right, kind of reminds everyone how heavy a lot of this material is. You got a crane, and you're going to just slowly lower that equipment, the piping down into the hole, and then connect it and make the connection as the image on the left, and then backfill in the compact in the image on the right, and reestablish that piping intertie. This is an example of a call out in the middle of the night, so sometimes we talk about our on-call staff. They get a call, they might be cozy in bed, doom scrolling on their phone, and the next thing you know, they're out on Navajo at 1 o'clock in the morning, looking at a meter box shooting water 40 feet in the air. It's just an adventure every single night, right? And so hats off to the guys that go out and do that work and makes the fix.
That's on the homeowner side of the line?
This would be our CCWD side. So part of the art is determining that, though, trying to understand. And obviously, in a situation like this, you're going to have to slow the water down to see what's really going on in the image on the left. But yeah, that's a lot of the conversations that happen between on-call and customers is trying to understand and get them to be able to give you a little bit more information so you can get an assessment of what's happening. Because when you deploy, it's a lot. And so you want to make sure that it's a district issue. In this case,
photo on the right, where you look at 1 o'clock in the morning?
that's not me. No, that is our illustrious collection worker, Tommy, who seems to be everywhere all at the same time. He does have a great haircut. I love his haircut. But, the image in the center, you can kind of see like what they're cleaning off, so all of that debris shot out of that meter box, AB and sand all over the place. And it looks like it's right next to, like a concrete landing or maybe a part of a driveway or a porch almost, if you will.
Is that unusual to have that kind of debris in one of our water lines before it gets to a homeowner?
Well, it wasn't in the line. It actually, when the leak happened, the pressure, like we were talking about, blew all the material around the line out and then just blew it out onto the asphalt or the concrete next door. Yeah. And so our guys, they're not going to just drive off and let that, pile of debris sit over here where, they're going to clean up the mess, and that's what they're doing there. Here's an example of replacing or cutting in a 6-inch valve in the image on the right. And then also replacing a leaking 2-inch tap. And we're diving into some here's some unique failures that happened. A tree fell on the roof of Big Tree's tank 4 and poked 4 holes in it as it fell. And so, this was day after Christmas. Our crews are kind of assessing some of the damage. You're not going to necessarily get a call from SCADA about a tank with a tree on top of it. Right?
How old's that tank?
3 years old.
Okay.
And so, it's imperative that we get those holes covered up ASAP. So our crews are up there. You can see the center image. So our mechanic is tied off. He has basically a fall protection lanyard that's connected to the railing of the basically the ladder of the tank. But our distribution crew leader is holding it so it doesn't get caught up on anything while he's trying to move on the top of the tank. So you're kind of holding this lanyard up. You've got a coworker out on top of the tank who's riveting disinfected aluminum covers on over those holes. And you can see in the image on the right, those little square metal squares that are on top of the roof there. So hats off to the guys, coming after Christmas, might have drank too much eggnog the night before, and the next thing you know, you're on top of a
sloppy,
20-foot
wet conditions. Yeah.
Right. Yeah. This is a great example of making do with what you have. The raw line vault at Sheep Ranch is an interesting vault in and of itself. In that vault, there's a 2-inch valve and check that failed. And so our distribution crew and our construction crew went up there and worked together, and you can see them on the right. They installed a new 2-inch valve and check valve So the brass there, the image on the right, and then the image on the left, you can see that the existing check had essentially split. And so this takes water off of Sheep Ranch pipeline conveyance from San Antonio Creek, and then it pumps it up the hill to the Sheep Ranch water treatment facility, where it's then treated for use in the community. So that the image on the right is the raw water vault. And then our mechanics then turned around and worked with the operators to install a new backflow device at the Sheep Ranch water treatment plant. The old one was quite old and in need of replacement, which is that image on the right. And then you can see the brand new check in the image on the right here with new valves and everything installed. Sometimes you got to cut things, sometimes you got to weld out in the field. The image on the left illustrates some of that. Here's an example of our construction crew working with our electrical team up on Fowler Peak to install our two-way radio telemetry. So where the sheriff's department was kind enough to allow us to put a slab up there and add some of our two-way radio equipment so we can continue to have conversations with each other when cell networks go down and whatnot on the two-way radio system, which is really key for us. Some more work with the electrical team, repairing aerators at the Upper Pond La Quintana Waste Plant. You can see how big the aerators are before they go down into the pond. Annual flow meter calibrations. These happen every single year. Our electricians go out and calibrate all the flow meters that we have out in all of our systems. It takes quite a while. We do a great job with that. Here's an interesting one. You can see kind of the image on the left, how you're going to test your flow meter calibration. You're going to look at SCADA images of what was the flow 10 minutes ago before I calibrated this. What is the flow now? How far apart were we? What does the 4 to 20 milliamp signal tell us? And then the image on the right is an example of spending all night trying to find out what's going on with SCADA and realizing it was just a defective connector between two Ethernet cables. That's a great one. PG&E work at B-Tank and Copper, replacing secondary conduit. Our crews have to, basically work with PG&E to ensure that our facilities remain safe and aren't inadvertently damaged in their process. Here's a PLC CPU repair at La Quintana Waste Plant. So example, our electricians are out at all hours of the night making repairs. And then finally, we did publicly accept bids for the critical facility generator replacement project here in this boardroom, and anticipate bringing that next board.
I have a question. Some of our constituents have pointed out that our leakage kind of exceeds state standards. And I'd like to, unless you have a quick answer, ask that you, I don't want an in-depth answer, but I'm curious about, are we working to meet that state standard? What's the big picture on leakage? We have so much water that relative to the cost, it wouldn't be something we would do, but is that something that you're working on?
Absolutely. So the short answer is we're absolutely working on it. We have a utility crew that all they do is replace service laterals. Remember too, that we have 6 different distribution systems. So the severity of the issue varies depending on the service area that you're in. I don't think it's any secret that we've talked about La Quintana or Jenny Lind water system and the Copper Cove water system are the most leak prone, if you will. And so that's where the focus remains for the utility crew. Capital improvement projects also help to address this. We do have an understanding of how we have improved over time with both capital improvement projects, implementation, and then service lateral replacements. We are starting to see a shift in basically the amount of leakage that we have.
It's decreasing.
It's decreasing. The one thing to think about also is we really kind of reset the bar when we implemented the AMI project. And we're now getting to a point where we have data that's valuable to help us, to help inform us about where we're going, And that was kind of step number one. We need to be able to get that information and bring it into our system so we can push production up against that, and then we can get a real understanding of what's going on.
So there's a lot that goes into that. We've been having internal discussions about, when is the right time to bring a more detailed report to the board that gets into what the regulatory requirements are. It is one of the high priorities that drives, infrastructure decisions for us. But there's still a lot of imperfection in the data historically, and even, currently that we still need to resolve. And so we're trying to time that appropriately, but we'll bring a more detailed report back to the board on that.
The thing you got to recognize is the data that's out there today that a lot of people are making judgments on was basically being monitored by 40 and 50-year-old meters that we didn't believe were working. So that's why we replaced them with the AMI. So we're hoping to get more accurate data so we can actually find out what that loss is. And now we'll be able to isolate it so much better. So, there's a lot that goes into it. The AMI project should give us so much more information to help solve it.
That's good. When we were in San Diego, you and I met. I left you with the woman that has the company that does the projections on leakage and that kind of. Is that something? Was that all interested? That really applies more to urban areas than us, or?
Oh, no, that's absolutely applicable to us. There are few companies that provide that level of information. And so one of the things that's important that before we move towards some sort of smart kind of software, we need to kind of improve our information gathering out in the field. So not only is that with the meters, but part of the AMI project, provided $1 million grant funding that allowed us to buy pressure monitoring equipment for our PRVs. So when we deploy that equipment, we can now gather that information. And kind of like Michael said, this is kind of there's a lot of facets to this, but another component is additional system meters. And so we've talked about when we can kind of refine and drill down into different parts of the service area with additional meters and PRV equipment coupled with the AMI equipment, we could take advantage of a software like that sits on top of all of these things and then says, hey, this is a problem area. You're improving here, alert here. We're traveling down that for sure. Absolutely.
Thank you.
Any other questions, comments from the board? Awesome report, Damon. Any comments, public comment? Anything online? All right, well, thank you.
Damon, I wanted to ask you about that last thing that you mentioned about the new equipment that you could sit on top of a PRV. Last time I heard that, there were 4 of them that we obtained. Are they intended to be placed temporarily so that you can put some data and then take them to another spot, or they stay where they're put?
The current objective is to leave them where they're at. Yep. And I want to say it's closer to 25 or 30 cents.
Oh,
Yeah. So I think 5 of those are going down into the Jenny Lind area and the rest will be up on the pass. Is that correct? 10 in Jenny Lind, the rest on the pass. We could move them though. I think they're flexible enough that if we talk, hey guys, we need to move this, we're going to, we would just have to change probably the location parameters, the coordinates, all that kind of stuff.
okay, well, I took note about your slides that you only had one that showed a problem in the Copper Cove area. So
All right.
Things must be really good shape.
Yeah. Okay. I'll bring some more in for sure next time.
Thank you, Damon.
Thank you.
Awesome. All right, move.